his first collegiate home run. 1-0 pitch. Line drive down the left field line.
Baseball, America's favorite pastime. Most people think they know the basic rules of the game. The pitcher throws, the batter hits, 3 strikes, and you're out. But underneath it all, the rules that truly govern this game are the laws of physics.
When you go to a ball game, you're seeing all the interplay of force and velocity and projectile motion. It's a beautiful thing to see and watch.
Paul Robinson is a physics teacher at San Mateo High School and a rabid baseball fan. He uses the sport to teach his students about how the universe works.
Physics is a beautiful way to see the world that we live in. Being a student of physics just makes the game that much more interesting and fascinating.
A 95-mile-an-hour fastball will reach home plate in 0.4 of a second.
If you're a student of physics, it's likely you're familiar with this place, UC Berkeley. Home to 8 Nobel Prize winners, the physics department at Cal is second to none. But if it's the physics of baseball you're after, the best place for your fieldwork is on the other side of campus. We brought in a couple of ringers to show us what's going on.
Hi, I'm Linda Shore.
And I'm David Barker.
I'm a physicist, and we both work at the Exploratorium in San Francisco.
And we're here at Cal Berkeley campus, Evans Diamond, home of the Cal Bears baseball team. And Linda, I bet you did not know that there's a physics laboratory out there.
Well, I wouldn't have immediately thought about that, but I do know there's a lot of physics going on out there. I think what I want to do, though, is learn how to throw a baseball properly. So I think I'm going to spend some time with the Cal pitching coach here and see what he can teach me.
And my swing has been like a rusty gate lately, and my power numbers are down, so I think I'm going to go talk to the batting coach and see what I can learn.
Okay, well, good luck.
All right, good luck to you, too.
Instead of a pushing motion where I'm leading with my elbow, I'm trying to get on top of the baseball, and what I mean by that is...
Dan Hubbs is the pitching coach for the Cal Bears. It's his job to teach his players how to get the most out of their pitching motion.
With my fingers, and kind of let my lower half do the work and let my arm just kind of go for a ride and make the ball spin.
You know, as a physicist, when I think about that, I'm now realizing that what it really is about is momentum. That I have these big body parts at the bottom of my body, my legs and my hips.
Right.
And if I can turn those first and get those in motion first, then I can have that momentum go up my body to the smaller body parts that have less mass. I get more speed. Up the arm, less mass, more speed. Fingers, hardly any mass, a lot of speed. So it sounds like it's a whip motion.
Right.
It's
That's
a lot
exactly
like a whip.
right.
So I'm sort of going like that.
That would be right. We want to use our legs, we want to use our abs, we want to use our core to throw the baseball, and then the phrase we like to use is let your arm just kind of go for the ride.
But sending your arm on that ride is a surprisingly complex task. If you really want to see what works, watch someone who can throw some real heat. Using a 3D high-speed infrared 8-camera motion analysis system, we can see just how intricate the throwing motion is. The players wear reflective markers, which the computer can pick up, calculating exact body angles, joint velocities, and timing. It can also analyze the physical kinetics, or joint forces and torques, placed on the body. For big leaguers like San Francisco Giants ace Barry Zito, seeing this can help them make subtle changes in biomechanics to enhance performance and reduce injuries.
Baseball pitchers are great experimental physicists because they're constantly trying this, trying that to see what works.
5-4. Swing and a miss by Garfin, so just like that.
Newton's second law of motion tells us that the acceleration of an object is dependent upon 2 things: its mass and how much net force is acting on it. Translated? The harder you throw, the faster it goes. But pitching takes more than throwing hard. There are also external forces in play. Each pitch is fighting gravity and friction.
When a pitcher throws a ball, it has to push the air out of the way. When it leaves the pitcher's hand, this is going as fast as it's going to go. From that point on, friction slows it down. As a ball moves through the air, it's just the same, very similar to a swimmer swimming in water. The swimmer has to push the water out of the way. The water pushes back on the swimmer.
While external forces may cut down on momentum and velocity, a good pitcher will be able to use this to his advantage. Friction and gravity can make the ball do nasty things.
Strike 3 called, so
A curveball will spin up to 30 times a second and break as much as 17 inches.
Why is a curveball curved? For many years, it was actually thought to be an optical illusion. But it really does curve. How much? Depends on how fast you spin the ball. When a ball spins, it generates greater pressure on one side as it moves through the air than on the other side. And this difference in pressure is a form of lift. It's called the Magnus effect.
So how do you get a ball to curve?
Well, we'll use finger pressure on the baseball. So let's say we have the baseball here. What we try and do is we may try finger pressure with our middle finger here and let the ball, generally the ball will break away from your finger pressure.
And what does the pressure do? It actually makes the ball spin, doesn't it?
It makes the ball spin a little differently.
Okay, so if it's spinning like this turbulent air that surrounds the ball gets pushed in this direction. And so like a jet, the ball is then forced to move in this direction. So then you'll get a breaking ball like this. So really, I guess all a batter has to do, if they can manage it, is try to figure out what direction the front of the ball is spinning, because that's the direction that the ball is going to curve.
Bases loaded, 2 outs.
Baseball is a game of small differences, and it's all about timing. And so the pitcher's doing everything he can to throw off the timing of that batter.
A splitter looks like a fastball until velocity is lost and the bottom drops out.
Time to step up to the plate. Newton's third law of motion states, for every action, there is an equal and opposite reaction. Welcome to the world of hitting. Once the ball leaves the pitcher's hand, the batter has less than a half a second before it crosses the plate.
And this is going to be a base hit. This will at least tie the game. Maybe.
You've got to decide, swing, don't swing, what kind of ball, curveball, fastball, slider. You've got to make all those decisions in 0.2 seconds. It's almost a reaction instead of a thought process. Some say it's the hardest thing to do in sports. Round bat, hitting a round ball, that's not easy.
Coach John Zuber, a former major leaguer and a member of the Cal Hall of Fame, is an expert on teaching the art of hitting.
Then we let the body follow, and that's when we get our momentum out towards the.
So you're almost moving your hips and your hands at the same time. Should you have a heavy bat and a big long swing, like a big home run cut swinging from your heels? Or is it better to have a short, compact stroke that relies upon bat speed more than anything else? Do you have a
Well, I think bat
theory
speed,
on that?
Bat speed is the key to power. I need my hands to get from there to there, short and quick, as fast as possible.
Exactly.
So I need this weight and that muscle and torque and force, whatever you want to call it, to bang into that. And now I have a whole lot of stuff hitting the ball at the same time, which is going to propel it out towards the field.
In the olden days, bats were heavier, they're bigger, longer. Nowadays, they're shorter and lighter. And the reason for that is so that the batter can get the bat going as fast as possible. In terms of physics, it's actually a trade-off. The heavier the bat, the faster the ball is going to come off the bat. That's one thing. But the other thing is, the heavier the bat, the harder it is to get it to go fast.
Oh my Hernandez hits a high drive to left field, and you can forget about that one.
The collision of a ball on the bat lasts only about 1/1000th of a second. In an instant, the batter can exert up to 8,000 pounds of force on the baseball.
What determines the force that a bat hits the ball are two things primarily: how fast the ball was pitched and how fast the batter swings the bat. But when those two collide, it causes the ball to squish up to almost not quite half of its size. And it compresses like a spring, and then in a thousandth of a second, it springs off the bat. Faster, leaving faster than it came in, maybe 110 or as much as 120 miles an hour.
So is there like a particular place on the bat that's the best to try to hit the ball?
Yeah, you want to try to hit it on what they call the sweet spot, and, and the sweet spot is on metal bats or on aluminum bats. It's a little bit bigger than it is on the wood bat, but on the wood bat it's generally right in this area, right in here.
When you ring a bell, it vibrates, or you hit a gong or something like that, you can see it vibrating. When a ball hits a bat, the bat actually vibrates too. But there's a point on the bat where it doesn't vibrate. It's a so-called node.
The sweet spot relates to the nodes on the bat. A node is the point along a standing wave where the wave has minimal amplitude. When a ball hits a bat, it causes waves of vibration. So if a hitter gets the sweet spot onto the ball, there's less vibration, and the bat imparts all that kinetic energy into the hit.
If you hit the ball right on the sweet spot, right about here, then all of the angular momentum, all the swing of the bat is going into the ball. The bat's not rattling around like this, so that's also like when you hit one really good on the sweet spot, it's got that nice sound. It's sort of like a very quiet cracking sound, you know.
You need to know where the nodes are.
Baseball resonates through multiple aspects of science. There's classical mechanics, fluid dynamics, biology, and don't forget chaos theory.
So maybe next time you're at a baseball game, don't just pay attention to the game, look around and try to find some of the science and mathematics, the physics, the physiology, the biomechanics, because there's really a lot of good science and math going on here.
And as the great baseball philosopher Yogi Berra once said, you can observe a lot just by watching.